This is going to be a little bit of a review for those of you who've taken a quant or a stats class before. So we're going to talk about empirical social science. So I would like all of us, we're all master students here, so I'd like all of us to start thinking about ourselves as social scientists, right? Whether you're in CJ or PA or CP, we are all social scientists, right? We might be studying incidents of crime or access to given areas like parks or restrooms and things like that, right? We might be talking about how bureaucracies or nonprofits operate with one another. But at the heart of all of those things are people, right? We're understanding interactions or relationships between usually individuals and sometimes larger, multiple individuals, right? Um, so as social scientists, we try to understand the social world around us by doing empirical science, social science, or empirical social research. Um, and I say this to make a distinction between quote unquote, I've done my research and empirical social science or empirical research, right? Many of us have heard people say, go do your research. And especially in a time when there's a lot of disinformation and misinformation, people say, go do your own research, right? Well, yeah, that's a type of research, but it's not the kind of empirical research that we're talking about as social scientists or as experts, right? Empirical social science or empirical research requires a lot of uh, aspects, right? Right. It requires a lot of attention to certain kinds of things, right? Causation, right? We're looking at relationships between variables, right? Um, when we say go do your research, it's something else. It's just like basically Googling or looking it up, right? We talk a lot about sort of exploratory research and then empirical research, and there's a distinction there, right? So here we're talking about social science, right? We're trying to be scientists. And empirical social science is really, it concerns itself with two things: observing something, one, and then trying to explain the thing that you observed. So observations and explanation, it consists of those two things. In quantitative work, a lot of what we're doing is trying to tease out those observations. We collect some observations, we're concerned with the observations, and we're trying to tease out from a numerical standpoint what those observations mean, right? How are they related to one another? The explanation part of it is what we call theory. Many of us have probably heard about theory, like theories of crime or theories of um, social disorganization, right? Or theories of hierarchies, right? These kinds of things. And that's simply what they are, is just explanations for what's going on. So we take some observations and then we try to explain them. Here we're concerned with the observation piece of it. A big part of understanding the observation piece is understanding the unit of analysis that we're operating at. And the unit of analysis, oftentimes in social research, is concerned with either the individual level or the aggregate level. And here I give the example of individual level as individual person. And this is often it's particular to like sociology or psychology kinds of research. We're concerned with individuals, but it can be an individual group or an individual city. But to paint it more clearly for you, I'm going to use the soc and psych kinds of explanations, whereas individual would be one person, and then an aggregate level would be something like a family, multiple persons, organization, multiple persons, cities, counties, and states, right? A lot of people. So things can be broken down at various levels. We've probably seen something like this before where we know where are you looking at people and their relationships? Or are you looking at organizations and their relationships? Right? Those are two different things, two different levels of analysis. Many of us have probably seen an Excel spreadsheet before. In an Excel spreadsheet, that's often how data sets are depicted. Sometimes you'll be sent a data set and it comes in Excel spreadsheet format, whether that's an XLS file or a CSV file. They're just a spreadsheet with rows and columns. Observations are the things on the rows, right? So we see person 1, person 2, person 3, person 4. So the unit that we're measuring is going to be at the people level, the person level, right? So here we're looking at people. The unit, if, let's say we changed this and it said organization 1, organization 2, organization 3, the unit of analysis would be at the organization level, right? So it's important to know anytime you're dealing with a data set, what does each row represent, right? Later on down the road in this class, where I'm going to have you go through several repositories and pick out a data set that could help you answer your research question. And you'll need to know, how do they measure these things? They could be maybe not at the person individual level, they could be at the city level. So each row would represent a city, or each row could represent a state. Even more complex, each row could represent a time period, right? Year 1, year 2, year 3, year 4, year 5. Even more complex than that, it could represent an organization year, right? Organization 1 in year 1, organization 1 in year 2, organization 2 in year 1, 2 in year 2, so on and so forth. So it's important to understand what level you're working with before you can even start understanding what the variables mean, right? So we can pick that out. So every observation in that data set is going to have a list of variables. And variables are those things that vary, right? Variables vary, they change. They vary across observations. They can vary from time point to time point. For example, we have social class, age, race, sex, gender. All of these things are variables because across observations, there are going to be different levels. So, for example, how many of us are above 30? Some of us are above, some are below. So given that people have different values on that question is a variable, right? The scores vary from person to person. So above or below, they're going to vary from person to person. Right? So all of us are going to have different scores, right? If I ask you more specifically, what is your age? Chances are we'll have, maybe between 22 and 26, we'll have a couple of people. Between 26 and 30, we'll have a few more people. Between 30 and 35, we'll have another group of people. And then from, 35 and beyond, we'll have Dana.
One.
So what that means, we're going to have, different people vary across one another. They're going to have different values. Right? So that's what a variable is. Go back here. So where observations are going to be on the rows, the variables are going to be on the columns. Right? So we have an age variable, happiness variable, a race ethnicity variable. All of these are important for understanding whenever you finally get a data set. You can go out to one of these repositories. ICPSR has a bunch of different data sets. You'll collect it. You can open it up and figure out, okay, this is measured at the individual level, and here are the variables on the columns. How many variables exist? This is also important for when you're dealing with data sets in R. We'll open up a data set and it'll tell you this many observations with this many variables, just outlining that same way. So as you can see from that last slide, each observation has multiple variables, right? Person 1 has age, happiness, race, SES, so on and so forth. Person 2 has those same variables. So each observation has multiple variables, but each variable has multiple attributes. Well, what is an attribute? A variable itself is the properties of observation, so the cluster that we can explain it by. So race, ethnicity, age, sex, gender identity, right? All of these are variables, but attributes are those specific characteristics that explain a given person, right? So age is a variable, but the attribute, a person's attribute could be 26. Another person's attribute could be 32, right? So the attributes are the specific values for each observation. You can think of it sort of like this. Whereas on the left-hand side, we have the variable name, age, gender, occupation, race, ethnicity, social class, political views, whereas the attributes are the specific categories that exist within that variable. So age could be young, middle-aged, or old. It could be 0 to 100. Gender could be male, female, trans, other, right? Occupation, you can have a ton in a list of occupations, right? All of these things. So the attributes are the specific categories that exist within a variable. Can anyone tell me the given attributes for the SES variable. Lower, middle, upper. Easy, right? We can just look at that and see, at least from this snippet, the head of the data set, we can see there are 3 levels, right? A lower level, an upper level, and a middle level. Probably not as fine-grained as we would like, but that's what we get out of this data set. Again, you'll notice that when you start working with data sets, especially quantitative data sets, you'll see sometimes things aren't measured the best way, right? What does lower mean? What does upper mean? What does middle mean, right? What about upper middle? Right? All of these things are important. So we know what the attributes are. So in quantitative studies, what we're doing is assigning numbers to a given value, a given social attribute. So age is an easy one, right? We can assign, instead of saying young, middle-aged, old, we can say, okay, my age is 15. We're assigning a number to that given age. It becomes a little bit more difficult with different levels of measurement. Something like social class. What does a 1 on social class mean? What is 2? What is 3? Doesn't make as much sense, right? But it's important for us to recognize that we can attach numbers to these given attributes, and that helps us in our quantitative study, right? If we say that social class, a 3 would represent upper class, a 2 would indicate middle class, and 1 would indicate working or lower class, we would know that, okay, the higher up on that scale, the higher quote-unquote SES someone has, right? So that's just an indication, like we can start attaching numbers to things to run statistical analyses. We want to understand relationships between variables, and these, instead of just looking at like the breakdown of that table that I had there, we want to understand the relationship between SES and happiness, for example, right? We wouldn't want to look at the whole data set of the whole data set table of people's SES and happiness and just look back and forth and say, okay, well, it looks like many of the people, I guess, in the middle class tend to be higher on happiness. No, we want to understand statistically, is there a relationship, right? Without a shadow of a doubt, right? Is it greater than chance that middle class tend to be happier, or that upper class tend to be happier than everybody else, right? To understand that statistically, we need to run statistical methods, right? We need to attach numbers to them. So when we attach numbers to them, we have to give a breakdown. What kind of variable is it, right? I just gave the example, attaching 3 to upper class, 2 to middle class, 1 to lower class. Does 1, 2, and 3 mean anything meaningful? It might mean something theoretically, right? Upper class is higher than middle class is higher than lower class. But 1, 2, and 3 essentially don't mean anything, right? So we have to figure out, how do we know when those numbers mean something? Well, we have to know the breakdown of levels of measurement. We have these 3 levels of measurement: nominal, ordinal, and interval ratio level variables. I clump interval ratio together because interval and ratio are very similar. One just has a natural 0 point. So most of the time when you say interval, you're implying interval ratio. So I'll keep it at 3. So the most basic level is nominal. All it is a set of categories. So the attributes are just categories for the purpose of naming or labeling or classifying. So if we think of these variables: political party, religion, gender, college major, right? These are nominal variables. They are nominal variables because all you can do is place somebody within a given category or a given attribute within that variable. And you can't say that one category or attribute is better than another category attribute. Right? You might subjectively think that Republicans are better than Democrats, or Democrats are better than Republicans, or progressives are better than all of them, but that does not mean that they can objectively be ranked, right? So when we're thinking about nominal variables, all they are is just sort of a shuffling of categories, right? You can't place them in a rank order. So religion, for example, you can't rank order religion, right? One is not higher than the other. They are just what they are. Same for college major, same for gender, right? Same for sex. There's a special kind of nominal variable called a binary or dichotomous or quote unquote dummy variable. Most often it goes by binary. If you've seen like movies like with computer code or anything like that, binary is zeros and ones, right? Yes and no, or no and yes. Zero is no, yes is one. So it's just all it is a category, right? You're saying yes, I belong in this category. No, I do not belong in this category. So if you wanted to create a special kind of nominal variable called the binary variable, you could say, oh, well, if you want to change the race variable into a binary variable, you would say, I am black or not, or I am white or not. What about, education? I am college educated or not. Just the presence or the absence of that condition. So things like race, that's another nominal variable I have here. Gender and sex, those are nominal variables. Again, you can't rank order them. The next most sophisticated, or the moderate level of measurement, is ordinal measures. So with each level of measurement, we're becoming more and more sophisticated. So we add characteristics of that variable. So nominal variables, all you can do is put people in categories. You can just label them. I am black, I am white, I am other. With ordinal variables, you can categorize and label, much like a nominal variable, but you can also rank order them. So not only are you putting people in categories, but you can say this one is higher than this one is higher than this one. So the perfect example is social class, right? You can say I'm in upper class, I'm in upper middle, I'm middle class, I'm working class. So it meets those criteria of a nominal variable in that you're classifying into middle or classifying into upper or classifying into upper middle or working. And there's an implicit rank order to it. Right? Upper is higher than middle is higher than lower. So you can name, label, classify, and it can be ranked. Conservativeness, I'm very conservative, somewhat conservative, not at all conservative, right? Or not very, and then not at all, right? You can rank order those. One has higher levels of conservativeness than others. I say here that you can assign numbers to it, but those numbers lack an associated numerical value. And what I mean by that is that I can say that one is higher than the other. I can say that, again, upper classes rank 3, middle classes rank 2, working classes rank 1, but those numbers don't mean anything, right? What does having a 1 on social class mean? Nothing, right? If you went around telling somebody that your social class level is 1, they'd be like, okay, what even is that, right? So we as social scientists can attach those numbers, but they don't mean something in the real world. So while the numbers that we have here for ordinal variables don't necessarily mean anything, we can become more sophisticated in this ordinal level and have those numbers actually mean something for our next most sophisticated level. It's interval ratio. So interval ratio meets all the criteria of the previous non-sophisticated or less sophisticated levels of measurement, right? We have the classifying and labeling of the nominal variable, plus we add on the characteristic of rank ordering, right? We can rank order these things. But we also add on that there is an associated numerical value. And I add here that it's a meaningful value. And when I say meaningful is that 1, 2, and 3 aren't just like numbers that we threw on. 1, 2, and 3 are attached to something, and the distances between those numbers are equal. The perfect example of an interval ratio variable is income, right? Where it's measured in dollars, in cents, and less than that, right? Smaller than cents, right? So if we measure at the dollar level, each step that you take forward is $1 more. Each step that you take backward is $1 less, right? So if somebody says, I make $50,000 a year, that means that they make 50,000 steps more than somebody who makes 0 a year, right? So those steps have an associated value, and they are equal in each step. Right? If we go back to the idea of social class, and the steps are 1, 2, and 3, A step of 1 between working class and middle class is not going to be the same as the step from 2 to 3 between middle and upper class. Working class to middle class might both have highly educated individuals, right? They might all have people that are making more than $20,000 a year, right? So what really is distinctive about these classes? What's distinct? Like, it's not the income, maybe it's not the education, it's a bunch of different things. So those numbers aren't attached to anything when we assign them to SES, but when we assign it to income by itself, those steps mean something. Steps are numbers, steps are cents or dollars. SAT scores, age, each step is 1 year or one point. And then those are specifically interval variables, and ratio level variables are interval variables that have an associated natural 0 point. So in most cases, we just assume that interval variables have an associated 0 point. I'm going to assume that we've heard some of this before, and I'm not trying to trick anybody in saying, hey, is this an interval variable or a ratio variable? We'll treat them as IR variables and we'll move on. Here's an example from an older textbook. Right? Gender should be sex, not gender. Religiosity, right? It's not that important versus it's the most important thing in my life. IQ is interval, and then ratio is income, 0 to 100,000. What level of measurement is the SES variable? What about age here? What about race, ethnicity? So what is the function? Why do we do this? Why are we even doing this? The important thing to recognize or remember from maybe your undergrad or grad methods class is we're trying to search for statistical relationships between variables, right? So we're measuring something in our observations, and we want to see, did this thing that we measured for an individual relate to this other thing that we measured for that individual? But how do we what's the purpose? Like, what's the role of doing all of this? And the role comes back to this idea of sampling. Let's say we're interested in how to explain Americans' income levels. We know that if we wanted to do that for all Americans, there are 350 million Americans. If we wanted to observe or collect observations on all Americans, that would take us a long time, right? One, we need the resources to do that. We need the time, we need the energy. We don't have the money, we don't have the people power to actually do that. So instead of doing all that work, by the time, honestly, if we tried, we start now, we'd end 100 years from now, and even then we'd have to account for the people who passed away during that time and the people who were born during that time. So honestly, our work would never end. So the way that we account for that is by sampling. We take a small sample that looks very much like the population, and then we try to generalize. We try to find statistical relationships within our sample, and we say, because this sample looks so much like the population, whatever we find here in this small sample, we are very likely to find in the population. Right? So that's why we do that. So statistical analysis is just allowing us to rely on this idea of probability to say, given the probability of inclusion in our sample, we can say with a certain amount of certainty that what we find here in terms of quantitative relationships between variables is the same thing we find out there. Right? With numbers, we can do that. With things like narratives and discourse or perceptions and beliefs, it's much harder, right? The way that people talk about things is, different. But if we're looking at like incomes, it might be easier for us to make those statistical, what we call inferences to the population. Okay, I say that, right? Population, we know, is the universe of all observations, all people or all organizations or all families or all cities that exist. The sample is just a subset of that. In quantitative methods, I will point out that a lot of qualitative methods tend to be on the descriptive side, right? You might be interested in, the educational experiences of immigrant children, second generation immigrant children. You might be interested in that. And in a qualitative project, you can answer questions that are related to that, right? Like you can go out and find a convenient sample of immigrant families, get assent from their parents to talk to the children, and you talk to them about their educational experiences, right? And you can paint a picture of what's going on in their lives, paint a picture of their experiences, right? And this is the type of project that is very common in qualitative research. You'll find it'll tend to be more descriptive, right? I'm describing the experience of these people, right? I explicitly sought out these people and I want to describe those kinds of experiences. In quantitative research, we can do that, but we can also take an extra step because of the rules of probability, right? In sampling, we can take that extra step and say, okay, not only can we describe what's going on in the sample, but because the sample looks so close to the population, we can make inferences. We can generalize our findings from the sample to the population. So in empirical research, we can go through exploratory research, right? That's the Googling, I looked it up, do your own research. The next step is doing the descriptive kind of thing, where we're actually just describing, okay, in this sample that I collected, what's going on. And I'm just telling you, this is what's going on. This is what's going on in the sample. What we do in empirical social science is we try to get to this last stage of decision making, inferential statistics, where we want to say something more than just describing our sample. Relatedly, you probably heard this before, the difference between a statistic and a parameter, right? They're both quote unquote estimates, right? A mean is a statistic, a standard deviation is a statistic, but they can also be parameters. The distinction here is that a statistic is specifically for a sample, and a parameter is specifically for a population. So the mean could exist for both, but it all depends on what your observations include. If your observation includes all Americans and your study is trying to capture some outcome for all Americans, then you actually collected the population. So if you calculate the mean, it's not just a statistic for your sample because your sample is the population, therefore it is a parameter. I know that was a lot of gibberish coming your way, but what I was saying is we can calculate the same thing, one for a sample, one for a population, and they're going to be called different things, right? Statistic versus parameter. So if I said I calculated the mean as a parameter, right, the parameter estimate is for the mean is, and I give it to you, you know that because I said parameter estimate, I'm talking about me collecting data from the entirety, the universe, the population. Quick reminder, what we do as social scientists when we're doing empirical research is we're trying to examine relationships. We're talking about relationships between variables. Right? Variables, again, are those things that vary. And we have this idea of, measuring some aspect of society, measuring, getting our unit of analysis being people, and one variable is going to be race. And another variable that is measuring something of society is going to be income. And we want to see how does one's race relate to or influence their income, right? So we're just taking things that exist out there based on our units of analysis. We're taking things that exist out there. We're converting them to variables. And we're saying, as an empirical social scientist, we want to understand across all of my sampling, how do they relate to one another? How does X influence Y? How does the independent variable influence the dependent variable? Or conversely, how is Y influenced by our independent variable X? So it's important to not only know what unit of analysis you're looking at, right? What the population of the sample is, but also, the level of measurement that you're measuring, but even more importantly, what variable is which, right? What's my independent? What's my dependent variable? What's my X? What's my Y? And this is important because we want to get away from this idea of descriptive stuff and get towards inferential stuff, inferential statistics, generalizability. when we do generalizability stuff, it's looking at these bivariate relationships, these multivariate relationships between X and Y. First, we have to figure out what's X, what's Y. We know that the X variable is our independent variable, it's the predictor, it's the cause, the quote unquote cause. I say quote unquote cause because it's in social science, it's a little bit more difficult to call it a cause. And then the Y variable is the effect, quote unquote the effect, the outcome, the dependent variable. The X variable is the quote unquote cause, and the Y variable is the quote unquote effect, because this idea of causation, of causality in social science research is much more difficult to reach than it would be in something like a STEM field, right? Science, technology, engineering, mathematics. There's this thing called the experimental design. Right? In experimental designs, what we're trying to do is isolate one thing. We're trying to isolate one characteristic, one variable, and see if that one thing affects one other thing, right? So we do that oftentimes through an experimental design. What we're doing is randomly shuffling people, randomly sampling people, randomly assigning them to either the control group or the treatment group. Because we randomly sampled, randomly shuffled, randomly assigned, those two groups should look similar in all aspects, right? Similar breakdown of racial categories, similar breakdown of age, similar breakdown of income, if you have enough people, right? All of these things, they should look very similar. Then for the treatment group, you give them one thing, right? You have them take one drug, right? Prime example is vaccination trials, right? You give a placebo group and a treatment group, and then you see how they perform on some kind of outcome, right? Are the antibodies there or are they not? The only thing that you're changing is giving the treatment group the treatment, right? And if there's a positive outcome, you know that the only thing that could have caused the change in the outcome is the treatment. We're social scientists, though, and it's very difficult for us to do like randomized controlled trials unless we have a lot of resources, right? We have a lot of money. You know, like Moderna and Pfizer, they had a ton of money to do all this kind of research, right? For us, many times we don't have those capabilities, so we have to do a little bit more. We have to take a few extra steps to ensure causation. In experimental designs, you can find causation where it is because you're doing all those things. With us, it's harder to do experimental design, so we have to meet these three criteria. First, there needs to be an association. If you're going to say one thing causes another thing, right, the quote-unquote cause versus the quote-unquote effect, if you're going to say X causes the change in Y, then first you need an association. There needs to be some relationship, some statistical relationship between X and Y. So if you're saying education causes an increase in income, increase in education causes an increase in income, you're going to need to first show that X education is related to Y income in some statistical sense, whether that's I don't know, like a t-test or a correlation or something like that, an ANOVA or something like that. So you first need to show there's an association. Secondly, and relatedly to that first point, is there needs to be proper time ordering. So if you're saying something is the cause, it's causing something, right? And if it's causing something, it has to come before the outcome. It has to come before the effect. So I say time ordering means the cause X must precede or come before the effect Y. So if you're saying education comes before income, you're saying education leads to a change in income. You must be measuring education in this year and measuring income 2 years later, right? Or something like that. You can't say education causes a change in income, but measure income before you measure education. Right? How can it cause something that came before? Right? So that's why time ordering is important. And finally is this idea of non-spuriousness. Spuriousness is this idea that when you're looking at the relationship between two variables, there's some unexplained or unmeasured third variable that can explain the relationship between X and Y. There's always this example of shoe size and reading comprehension level. A researcher went out and looked at the shoe size of like a bunch of different people in like K through 12 and found that people with bigger shoes had more reading comprehension. So they said, look, there's a relationship between X and Y. Shoe size causes reading comprehension level. Now, let's take a step back. Does that make any sense? Shoe size would cause reading comprehension change? No, right? On its face, there's no validity, right? But they found an association. And they measured shoe size before they measured reading comprehension. So we met the first two criteria. But what about this third one? Well, if you take another step, some unexplained or unmeasured third variable is age. Age could explain the growth in shoe size, but also the growth in reading comprehension, right? But it was unmeasured. So what happens is when you throw in that third variable, age, the relationship between shoe size and reading comprehension goes away. And now the explainer is age. So what we're doing when we're trying to deal with spuriousness, we're trying to find non-spuriousness. So that means we have to throw in a third, a fourth, a fifth, a 16th variable. And once you've thrown in all of those potential causes or alternative causes, and you still find that X is strongly related to Y, then there's enough evidence in place that you can say there's a strong belief that X causes Y, because you've accounted for all of the other things that could also cause Y. So that's as close as we can get to experimental designs, is accounting for all those things that could explain.